Okay, so slackline picture, right?
My hands are smacking.
Big tree.
Looks like a sheep.
It's a sheep on a stick, man. That's what a tree looks like. You've never seen a tree?
It's a sheep's.
You're a forestry major. You should know this.
Yeah.
This should be like thing 5 about trees. They look like a sheep on a stick.
Yeah, but that's more like a palm tree versus pine tree.
Yeah. I haven't done appropriate trees for our bio. Thank you. Okay. In our setup, we have Zach.
Yep.
Why didn't label Zach on
Did you not? Oh, there's a point. And then a line down to Zach's foot, and then a line up to the other side.
Do I lose points if I curve the wire?
Yes. The wire is not, well, okay, it's hanging in a slight curve. No.
What if he has both feet down at the same time?
Okay, why do I think the wire is hanging in any kind of curve? That's
Because my
weird.
foot would be curved?
That's just
I don't know.
Just assume it's not too straight.
Let's just assume it's a point.
when it's flat.
Okay,
Time.
forget it.
It's probably got a very, very small curve.
You know
Yeah,
what?
it
Okay,
probably
it's
has a
gonna-
very
it's
small
gonna
curve
move
in
on.
it.
It's emphasized for emphasis.
At any rate, what are the things that are obviously acting on Zach here?
Gravity.
Gravity.
He obviously has gravity. So there's gravity acting on Zach.
On his crotch.
And he's obviously got some.
No, on it, that's his belly button.
Better be.
You have big.
Look, it's also his torso is all way too long. Sorry, Zach.
Oh no.
Sure,
I'm not that short. Come on.
now you're more proportionate.
I don't have a neck anymore.
I got the neck part exactly right. Sorry, Zach. All right. Anyway, I have gravity acting down. Now, why is Zach not accelerating in free fall towards the ground?
Because the line stops it.
Yeah, the only thing he's standing on is the line, right? So there's got to be some force that the line's exerting that goes up. You guys see that?
That's the normal.
But the line itself is only exerting a force this way. You guys see that? How about this line?
It's exerting a force that way.
That line's exerting a force this way. You guys see that?
It's trying to compensate for the tension. What are you doing?
Yeah, basically the tension is increasing to compensate for the fact that you're loading the line, right? So it goes from whatever the static load on the line is to when you're standing on it, right? That load peaks. And that load peak is once this thing is stretched out a little bit for your weight, right? So it's deflected down. And it's deflected down until it garners enough, like basically garners enough springiness to pull you back up. You guys with me on that? That's a little bit of a crude explanation, but whatever. So, my claim is that that part is decomposed into two pieces. Like, if you had to describe this vector to a friend, what would you say about the direction in which that thing's pulling?
It's pulling on the center of it toward the trees and pulling on the trees toward the center.
Okay, so I'm free body diagramming Zach, right?
Uh-huh.
If I was free body diagramming one of the trees, you guys see that?
Mm-hmm.
I would have some kind of a, okay, the line's pulling this way on the tree,
Yeah.
right? And then the ground is pushing that way on the tree, and gravity's pulling this way on the tree, and the normal force of the ground is pushing up on the tree, right? And all that stuff adds together to nothing, which is why the tree is not accelerating towards you.
That would be terrifying.
And then if it did add to something, then it means that the tree is accelerating at what rate?
Yeah, we would have to figure out at what rate the tree is accelerating, right? But yeah, if the tree was accelerating towards you, that would be a scary proposition.
Obviously, yeah. But
It should be noted that when I learned about doing this calculation, the way I realized that you can exert almost infinite force with a slack line was I got the acceleration on my mom's clothesline post to be non-zero.
ooh, did you break it?
Yeah, she was kind of pissed. It was a 12 by 12 post, right? Like a big a like ridiculously overbuilt post, buried 6 feet in the ground, and
It's a small tree. Like,
yeah, it's not that big a tree. It doesn't have any roots on it. The ground's pretty soft at that time of year, so I pulled it over.
Nice.
Like, I kept noticing that the slackline kept getting looser and looser. So I'd go tighten it, and then walk on it some more, and it'd get looser. So I'd tighten it again, and walk on it again. So just a little bit at a time, right? What I want you to note about this thing, though, right, is there's a horizontal part of this vector, right, like an over part, and then there's an up part. See that? And then on this guy, there's an over part and an up part. So I might call this like, this is like the tension over piece, and this is like the tension up piece, and this is just the tension itself.
Yeah.
You guys see that? And then what can I assume about the other one?
Same
the
thing.
same.
It's probably a mirror image, right? Why is it important that it's a mirror image and not the same thing?
Because you're standing in the middle.
Yeah, you're standing in the middle and you're not being accelerated towards one of the ends by the line, right? So I know that the tension over this way
Should equal the tension
Cancels
out.
out the other.
and the tension over that way have to cancel each other out. You guys see that? And then what else do I know cancels? So these two cancel.
The tension up.
Up in the gravity.
The ups and the gravity have to cancel, which means that the tension up component has to be
Equal to the, or to cancel out the gravity.
has to cancel out with gravity when you add it to the other one.
Both of them combined.
You guys see that? So both of them combined have to add to gravity. So each of them is how much of gravity?
Half of gravity.
Half of gravity. And then how can you figure out what the tension over is?
Pythagorean theorem.
Yeah, you can use the Pythagorean theorem because we were able to measure the tension on the line with the dynamometer. Or we also got some numbers, right?
Yeah, 30 feet, so you have.
We know how far this is and how far that is,
So
right?
you can find the angle,
So we could find the angle here, which is the angle here,
and then you could use the
and then we
tension
could,
gap, which we can calculate based on his weight.
You just soak it over.
yeah, we can just Sokotoa the heck out of this thing. You guys cool with that? So I don't think I have time to do that calculation, but do you guys trust that that calculation could be done?
Yes.
Okay.
With the given information, I concur.
One thing I want you to note about this, what happens is the angle theta goes to 0. In other words, what happens is I tighten this line up so that it gets closer to horizontal.
If when I'm on there still? Or,
Yeah. Yeah, so if Zach's on there, as theta goes to 0,
So the up force is the same, but the tension out force is just a lot higher.
So.
yeah, you guys see that? The tension up, right, is still going to have to cancel half of gravity.
Right, but the tension
But
out.
now this angle is going to get really close to 0, right?
So then tension
The
out
tension has to be crazy.
So the tension out's going to have to get crazy big.
to compensate for my weight.
And then what's the tension on the line? Well, it's
Crazy big.
those two chunks, right, stuck together. You see that?
Crazy big.
So as this gets crazy big, the tension gets crazy big, which means that,
Snaps.
You're gonna have some equipment failure at some point.
yeah, this means that you're going to experience equipment failure regardless of equipment. You will never be able to get this to be totally horizontal with real world equipment. It will all part eventually.
Even if your equipment was like virtually indestructible, the trees you're using, so they could.
Yeah, something in the system is going to fail.
Right.
And this is part of that, this goes back to that kind of concrete bridge thing, right? Because that would be the horizontal case.
Mm-hmm.
You guys see that? So horizontal ain't gonna happen. So it's not that everything as a spring is bad for you. Everything as a spring is actually good. Right? Because if it didn't have a little give in it, it would break. You guys imagine trying this with a piece of glass?
No. Zach's gonna lose his
You could
legs.
imagine, wouldn't last very long.
So what if you use something like, if you slimmed this down, right? Like to, yay big or so? You guys ever seen anything class about yay big that you like set stuff on the middle of?
A glass table.
Yeah. Why isn't that just shattered?
Support.
This glass bends a little bit. Is
Just
that-
a little
So
bit, like
when
when
you
you're.
have-
your
Yeah,
windows
not a
are-
ton, just a little bit. And a little bit's enough to keep that force from being infinite, right? It's actually finite and some value that glass can withstand.
So if,
And that is why you don't jump on glass tables, right? Because as you increase this weight in here, right, the ups have to get bigger and the outs have to get also correspondingly bigger.
so if you have, would you say instead of going back to being flat, it would go back to being at its resting point? Because what if you have a slight arch, and then the weight causes it to become flat?
So in an arch, you get away with something.
Yeah, because.
So if you have an arch, right,
Uh-huh.
then you have this force up, but the ground is also kind of pushing up on the ends, right?
So when you have.
This is a little
downward-
different than the horizontal case, right?
When you have a downward force, it cancels out the upward push.
Yeah.
right? And then
You
you
just
have
kinda
a
see that?
flat surface.
So this is the idea behind that pre-tensioning that I was talking about with that bridge. You tension it to get a little arch in it, and then when you sit on it, it gets a little flat.
That's why you see like the big trailers with the big tractors and stuff, they're arched.
Yeah.
Tractors.
Yeah, this is why you might make something arched at the beginning, so that you don't have to deal with this kind of problem. You can deal with it differently.